Okay, so yesterday we learned how to integrate 1 over x, or just in general, a derivative over itself, and we would get natural log. Remember, we had the absolute value bars around the log argument. And then we also talked about some trig integrals. You already know how to integrate sine and cosine because it's very similar to the derivatives. Yesterday, integrating tan was new, and integrating all of these, the rest of these, was new. What I would suggest is that you already have the top two memorized. This week, focus on memorizing these two. They're similar to each other, so maybe memorize one and then the relationship to get to the other one. And then next week, focus maybe on memorizing these last two. Okay, just don't wait till the last minute, because then they're going to get all scrambled. If you forget how to integrate tan u, or tan x, what could you do?
Sine over cosine.
Yeah, replace it with sine over cosine, do a u substitution, and then you get it. That's how you get it. That's how we did it yesterday for the first time. And so that's how you can do those problems, but you can watch what if you haven't memorized. And like I said, I think this week, memorizing these two, that's a doable task. And then next week, the other two, that's doable. Okay, so let's look at example 1. And we're going to evaluate this definite integral, so we have bounds. Now, if we do a u substitution, we know we're going to have to change those bounds. So let me ask you, do you think this is a u substitution problem?
Yeah.
Okay, it kind of seems like that, right? Because it's complicated. So what are you going to let u equal? Okay, so I'm going to write something down, but I don't want you to write it down. I want you just to watch. So we're going to let u equal 1 plus tan squared. So then remember, the next one is then what's du. Now we got to derive tan squared. And if you notice, there's nothing else left over, so this is not going to work. Okay? So I heard, okay, well, let's just let u be tan. Still, du then would be secant squared, which is not there. Okay, so we kind of have a problem. And so this is when you got to say, okay, let's back it up for a minute, because it seemed like this was u substitution, but maybe I'm missing something a little bit more obvious. Maybe we can simplify Pythagorean identity. What is 1 plus tan squared the same as? Secant squared. Some of you remember your identities very well. Now, for the rest of you, I'm going to tell you how you can remember this. All right. We'll come back to this in just a minute. Okay. Side note, you should know the identity sine x squared plus cosine squared equals 1. Now, if you divide everything by sine squared, you get 1 plus cotangent squared equals cosecant squared. Again, I got that by dividing each of these three things by sine squared. If you divide each of these three things by cosine squared, you get tan squared x plus 1 equals secant squared. This is why you did trig proofs for a long time last year. It's so that you get used to these identities. Okay, these are called Pythagorean identities. So that's how I knew to replace that. All right, so back to this problem. What else can we do to simplify? Square root of secant squared. That's just secant. All right, now here's the thing. We don't know how to integrate secant unless we use this identity right here. This, it's not really, I shouldn't say identity, this integral rule. Okay, what you would have to do instead is rewrite secant as 1 over cosine and use a weird, you'd have to use more trig identities. And so this is why it's just worth it. I already had to use trig identities. It's worth it just to say, okay, well then that means I know that this integrates to natural log absolute value of secant x plus tan x. I don't need the plus c because I have bounds. We're going to plug these numbers in now. So natural log of secant pi over 4 plus tan pi over 4. Okay, I'm going to go a line below. Minus natural log of secant 0 plus tan 0. Okay, this is your answer. It is not simplified at all, but it is your answer. If the direction said to simplify, you'd have to say, okay, this is 45 degrees, what's secant of 45, and then you go on from there. Okay, that's not the focus of today's lesson. All right, any questions on that? I just use this identity, or this, I keep saying identity. I use this integral rule. Mm-hmm. You have a quiz Thursday. Tomorrow we review.
We'll have to have those memorized.
You need, I would say, I had told you tan and cotan, those are ones you need to have memorized, but if you didn't memorize them, you could still do them. The bottom two are a lot more difficult. I don't expect you to have those memorized this week. By the test, yes. Okay, so let's move on to example 2. All right, when we have a dy over dx, what's your first step before we're going to integrate both sides? What are we going to do?
dx.
We're going to move that dx over to the other side. And so now we're going to integrate. And we're going to integrate dy, and we're going to integrate 3 over 2 minus x dx. Now the left side's just y, so that's easy. And the right side could have been on your homework last night. Okay, so one thing that will make this problem easier is if I move this 3 to the front. So, like this. Moving those numbers to the front is always going to make the problem easier. Some of you may know exactly what the integral is, but I want to go ahead and lead us through u substitution here. So we're going to let the denominator be u. This is like what we did yesterday. Then what would du equal?
Negative dx. Which is
Yeah.
negative dx.
Negative dx, and I would move that negative over to the du. So really what this means is a negative is going to go out in front, so that's really going to be negative 3. And when I do the u substitution, 1 over 2 minus x becomes 1 over u, and the dx becomes du. Technically negative du, but we took care of that when I put the negative in front. Okay, at this point, when you see this, you should know immediately what that integrates. What's the antiderivative of that?
Negative 3 natural log.
Yeah, natural log of u. So this becomes negative 3 natural log absolute value bar of u, or absolute value of u, plus c. And then my really final answer would be where we go ahead and plug in the x term.
You said it's okay if we don't show that the use and absolute value and just go straight to that.
Usually, yeah, this is your final. Really, I think some of you are good to go straight from here to here.
Yeah.
I think you can do that. That's not too bad. If you're making mistakes, don't do that. But as we practice this more, I think that some of you you'll be able to do that, and it'll be great. If this was multiple choice or if you're checking an answer, it's possible that they made negative 3 become the exponent on the log argument. I'm not expecting you to do that, but I want you to be aware of it so that you'll know if your answer is right or not. Okay, so we're just basically kind of hitting all the stuff we know about integrating and using the natural log. So example 3 is talking about big F prime, where big F is an integral. So how do you take a derivative of an integral? Or what happens when you try to derive an integral? Yeah, the integral goes away, and that means that this 1 over t, that function's not changing. I'm not integrating it, I'm not deriving it, it stays 1 over t. Now you're still going to plug in your bounds, and what also are you going to do with those bounds?
Change the names.
You're going to Well, if we're doing a U substitution, we're going to change them. We're going to take the derivative. Basically, kind of like chain rule. This is the second fundamental theorem of calculus. It's been a while since we talked. Well, I think we talked about it last week, but it hasn't been a big emphasis in here. So anytime you're trying to derive an integral with bounds, okay, you're going to go ahead, keep the function the same, 1 over t. You're going to plug in your bounds. 1 over 3x. But before I move on, I need to multiply by the derivative of that bound. So what would be the derivative of the bound 3x? 3. Okay, minus. Now I'm going to plug in the lower bound. 1 over x times the derivative of the lower bound, which is 1. Okay, so I'm not actually integrating or deriving. They can't basically cancel each other out. I'm still going to plug in the bounds, and I'm going to, basically this is like chain rule. I'm going to multiply by the derivative of the bound. All right, what does this simplify to?
1 over x minus 2 over x.
Which is?
0 times 1 is 0.
0. Okay, so moving on to what seems like a completely different problem. Area. If this said to estimate the area, and I didn't give you this equation, and I just gave you the graph, how would you estimate that area? Trapezoid, rectangles, Riemann sum, something like that. It doesn't say estimate, it says find. That means our answer should be exact. So we're going to integrate. Now the bounds here are important. You've got to make sure that you either look at your picture or they may tell you. My lower bound is going to be 0, and my upper bound is going to be 4. Okay, notice that I'm using the x values for my bounds. Don't use the y's, 0 to 1. Use the x's, 0 to 4. So 0 to 4, and I'm going to go ahead and write the equation, or the function. And again, at this point, this is something that we've already done. Okay, so how are we going to integrate this? U substitution. What should u equal? Yeah, the denominator. That makes du 2x dx, which is nice because I don't even have to divide that 2 over. It's exactly what I want. So all of this that I circled is du. Now, I'm going to need to change these bounds, unless I want to go back to x in the end. But I'm gonna once I go to u, I'm going to stay in u, so I need to change these numbers. So what would 4 change into? 17? Any of you thinking 9? I've heard that a lot today. Y'all too smart for that? Okay.
You said it was just squared plus 1.
Yeah, you just plug it into your u equation, so the number squared plus 1. Okay, so now I have 1 over u du, and I don't have any other numbers like 1/2 or anything because the 2 was already there. Alright, so this means that 1 over u du, we know that that's natural log of u. Then all I gotta do is plug in my bounds. Natural log of 17 minus natural log of 1. I dropped the absolute value bars because these numbers are positive, so I can do that. Can I drop anything else? Yeah, natural log of 1 is 0. So really my final answer is natural log of 17. Now, it's possible that given a multiple choice, or you may want to write this as a decimal. That's totally fine. Your calculator does that. Just make sure that you're rounding accurately to 3 decimal places. If you think after all day today, I have this one memorized. So this is about 2.833. And the nice thing about the decimal is you can kind of gauge whether your answer is reasonable. All right, now look at this. 4 by 1. This whole rectangle here is 4 units, square units. we're saying that our area is 2.833. Does that seem reasonable to you? Yeah. If you make like a really tiny mistake, let's say you did the 2 wrong or 1/2 or something, you might get an answer that's way off. And that's good to know that you can check that. All right, now we're not done with the notes, but what I want to tell you is your homework tonight is basically just over these types of problems. Okay, I do want to go ahead and talk a little bit about some of these other problems that we've seen on the after parties. And you're not going to have homework over this tonight. It's going to be homework Thursday night when you, like after the quiz, this is what you're going to work on. And I'm not going to be here, so it'll be a sub. But I wanted to go ahead and give you notes on this so that you're prepared. And really, a lot of this you should already know, but there's tiny little things I want to make sure that I actually teach this in class instead of just helping people as they come in. So first thing is average value. Let me go back up here. There is a very specific formula for average value. We had this on our last test. And what the average value represents is the height of the perfect rectangle that's the exact same area as the messy area of the integral. Okay? And the B and the A, those tell you about the width, the X, the width. So it's kind of like the integral is the area of that rectangle. We divide it basically by the width of the rectangle that gives us the height. Okay, this is called f of c. We had this on the last test, and then sometimes I ask you to find c. All right, so when you see the word average, there's 2 different type of contexts that I could be talking about average. One is average rate of change. Okay, so like if I was talking about average speed, I might be talking about AROC, average rate of change, slope. But price is not a rate of change. Okay, that's your clue that we're talking about an average value. All right, that means we're going to integrate. And so we have an A and we have a B. And so the average price P is going to be 1 over 50 minus 40. And then we're going to integrate from 40 to 50 our expression here. Okay, so 90,000 over 400 plus 3x dx. All right, now you got a few options, but this is definitely going to be a calculator problem. Okay, so what I'm going to encourage you to do is this whole integral in your calculator. Some of you are really good at this, but a lot of you need more practice. Okay, so on the calculator, I'm going to go to the home screen and I'm going to integrate this function right here. Okay, so 90,000 divided by, and you need to put that denominator in parentheses, and if I just did comma x close parentheses, oops, yeah, if I just did comma x, okay, that would give you the integration expression, but then you're going to have to plug in 50 and 40 and subtract and all that. Your calculator will do the bounds for you. 40, 50. Okay, the other thing that I'm going to encourage you to do is to immediately do diamond enter. Because you know how your calculator gives you that exact answer a lot, especially when it's in auto mode? Just, if you know you're going to do diamond enter, just go ahead and do diamond enter. And this takes a second because, you know, it's calculating all of it. The other thing I want you to notice is what it has right here is exactly what I've written. If you mess up the parentheses, you should be able to tell when you look back up at this, what we call pretty print. And so I still need to multiply this by 1/10. Sorry, I'll pull this back up. I still need to multiply this by 1/10 or divide by 10. Okay? So I'm going to do that. Divide 10. And obviously, the decimal place just went over one spot. Probably could have done that in our head. Okay? So that's going to be 168, and you just need to make sure you round correctly to 3 decimal places. Now this is talking about a price. It doesn't really tell us this is in dollars and cents, but maybe we can assume that. And you could definitely say, oh, this is 27 or 26, but I want you to know, in banks, you know, they don't just round off to the nearest cent like all the time. Okay, they use fractions of a penny, and I mean, and whether they do it to your advantage or their advantage, you know, ends up making a lot of money. So, yeah, with gas, so we can see that's like 99 cents, 0.99, so a 99th of a cent. Okay, so I'm gonna go ahead and just leave it like that. All right, let's look at the next part. I call these PVA. What do you think PVA stands for? I mean, I've told you this, but.
Particle velocity acceleration.
So, velocity acceleration, the P here could stand for particle, but I'm going to say it stands for position.
Position.
Because from position to velocity to acceleration, you're taking the derivative as you move forward, and you're integrating as you go backwards. Okay? A particle that's moving along the x-axis is going right when the velocity is negative, and left when the velocity, or sorry, right when the velocity is positive, left when the velocity is negative. Okay, remember, velocity is just speed with the direction. And then here we have a velocity expression. So we're already starting in the middle. So if they ask us about acceleration, we're going to have to find the derivative. If they ask us about position, we're going to do the integral. This is just some review. This isn't new stuff. I mean, I've gone over this, but a few little things here and there you're going to notice, especially from this week's after party. All right, and by the way, this should say, let's let time be greater than or equal to 0. All right, so it says, in which direction is the particle moving at time t? T equals 1.5. So what are we looking for here? What's positive or negative? The velocity, right? So we're going to do v of 1.5, which means we're going to do 1.5 squared minus 4 over 1.5. And feel free to use your calculator. I believe you get negative 7/6. Someone can double check my memory. And so that means that this particle is moving left, because v of 1.5 is negative. So again, a lot of stuff we've been doing, but I just want to spend a little bit of class time going over it, because many of you are asking the same questions. Okay, acceleration. What do we need to do from velocity to get acceleration?
Derive it.
We need to derive it. Okay, what I'm going to do today is encourage you to derive this in your calculator. All right? This is kind of like review this, but it's also, let's make sure everybody knows how to do all this stuff in your calculator. So we're going to differentiate. I'm going to have to be clever with my parentheses here. X squared, I could be using t, that would be okay. And I get, I'm going to write it as t squared plus 4 over t squared. How would you derive this by hand? Quotient rule. Any other ways? I could separate this out into being t minus 4 over t.
You bring t to the top.
I can bring t to the top and do product rule. You have a lot of options here. So if one thing seems difficult, try something else. So now we want to find the acceleration at this particular time. So I want to find a of 1.5. So again, I'm going to plug in 1.5. And you could just do this calculation. You could also store 1.5 in for x or t or whatever variable you use to go back and select this, and it'll compute that for you. And I believe you get 25 over 9. Now there are no units here. They weren't given. You can't just assume they're meters per second. In calculus, they could be anything. It's not like physics where you're pretty much always a metric system. And so if they don't give you units, you don't have to write units. But if they give you units, got to use those units. Okay. Then part C goes, is the particle's speed increasing or decreasing? So this is saying, regardless of direction, are we speeding up or are we slowing down? Given that velocity is negative, and now we know that acceleration is positive.
Speeding up.
Yeah, it's speeding up.
One of you is right. The others are wrong.
The negative for the velocity doesn't tell you like increasing or decreasing, it tells you the direction.
Okay, so let's, we're all thinking good stuff, but obviously somebody or some bodies are wrong, and maybe other people are like, I don't know which one it is. All right, so let's kind of break this down, okay? If the speed is increasing, the easiest way, the easiest scenario would be when both the velocity, okay, take that, plus. When the velocity is positive, you're going forwards, and acceleration is positive. This is like when you're going onto a highway and you're pressing on the gas and you're going faster and faster and faster. That's the easiest probably scenario to think about, especially if you're driving, okay? The other one that's probably easy to think about is you're decreasing, okay? You're decreasing when your velocity is positive, but the acceleration is negative. Okay, this is, you're still going forward, velocity is positive, but if acceleration is negative, this means you've either let up off the gas or you're braking. This is maybe exiting the highway or coming to a stop sign. Okay, when you're going forward, those are the easiest ones to visualize. Okay, so now what I want you to think about, before I get to this one, I want you to think about what happens when both are negative. Yeah, so when the velocity is negative and your acceleration is negative, your velocity is decreasing. So imagine this. I'm in a car, I'm backing up, and I start out going negative 2 miles an hour, meaning I'm just reversing 2 miles an hour. Then I go negative 4 miles an hour, negative 10 miles an hour, negative 20 miles an hour. Hopefully you're not backing up that fast. But think about it. Your velocity is negative, and negative 2, negative 4, negative 5, negative 10. What's happening to velocity? Is it increasing or decreasing?
Decreasing.
Velocity is decreasing. Look, if you go negative 2, negative 4, negative 6, those numbers are decreasing. They are going down on the number line scale. But your speed is still increasing. This is why this is confusing. It's hard to think about speed when you're really thinking about velocity. It's easy to get them mixed up. All right, so that means that the fourth one, by logic, should probably go over here. And it does, and let me kind of give you a scenario of when this would happen. Let's say I'm reversing, and I just gun it, like I'm like backing out, but then I start to slow down. So it's like negative 10 miles an hour, negative 8 miles an hour, negative 6 miles an hour. Eventually I'm going to hit 0 and then probably go forward if I continue in that pattern. That's a positive acceleration. The confusing part about this is thinking about negative numbers getting bigger. We think that's an increase. But when a negative number goes from negative 4 to negative 14 to negative 100, that's a decrease, really, even though that's speeding up. So with all that being said, if you're confused or you're just like, I don't know how I'm ever going to remember this, I can't think this through, okay? When both velocity and acceleration have the same sign, your speed's increasing. I like to think of it this way. They're working together. They're working together to move you along, okay? When velocity and acceleration have a different sign, your speed's decreasing. And it's not exactly like this. I mean, if it helps you remember it, they're kind of working against each other. Okay, your direction and your amount of acceleration is working against each other. So, what's our answer?
Decreasing.
Decreasing.
D1.5 is less than 0.
Yep, because we have a velocity that's negative and we have an acceleration that's positive,
Yeah.
which is what was happening, we said. All right, so let's look at D. By the way, D, this little S right here should be an X. That's a mistake. A lot of times for position, we use S. On this problem, they're using X. So they're saying, given that X of t is the position of the particle, and they give us some information, but we need to find X of t first. So how do we go from velocity back to position? Integrate, right? So we're going to integrate the velocity. If we were going to do this by hand, we definitely need to break this up. Okay, we would need to break this up, and then we'd have some natural log. I'm going to encourage you to use your calculator. Just as practice. If you're like, I got the calculator thing, then maybe you don't need to practice. But some of you always do it by hand because it's easier for you, and that's great, but some of these are going to get really difficult. I don't want you spending all your time trying to do the algebra. Okay, so we get, x squared over 2 minus 4 natural log of x. And I'm going to write it right here. And then I'm going to go ahead and add plus c because I haven't done any bounds or anything, so I know the plus c should be there. All right, I haven't finished. That was really just the prep work. Because then they tell me that x of 1 equals 5. How am I going to use that information?
5 is equal to...
I'm going to plug in 1, and I'm going to set it equal to 5. So 1 squared over 2 minus 4 natural log of 1 plus c equals 5. The nice thing about natural log of 1, that's 0. You really get 1/2 plus c equals 5. You end up getting 9/2, so 4.5 for C. So truly my x is plus 9/2 at the end. I still haven't really answered the question though. The question is, what is x of 2? So all I got to do is plug 2 in now. This is an acceptable answer, by the way. It is a number. Let's go ahead. Somebody plug this in and see what we get as a decimal. I can't pull up my calculator. It's going to go right over this writing. We'll see if 2 people get the same answer. All right, while they're doing that, did you get it? 8.2? I think it. Well, what does it sound familiar? But that doesn't mean a whole lot. 2 minus 4 natural log 2 plus 4.5. I'm going to hit diamond enter. Yeah, I got 3.727. That's right. This brings up a good point. It's easy to say, yeah, I know how to type that in, but then all these little weird things happen here all the time on after parties. Like, I can't get my calculator to work. Well, you got to practice it. All right, party. The very last problem on the after party that's due Thursday is just like party. Okay, just like it. Total distance. What is implied with total distance? The direction doesn't matter. You go forward, you go backwards. It's not about how far you are from where you started, okay? This is just about like a odometer. Like this just measures how far you've gone, okay? And so what this, if direction doesn't matter, then that means, you know, I'm going to integrate, right? I have to do something with velocity. To get the total distance, I've got to integrate velocity. But more than that, I need to take absolute value of that velocity. We saw this in the last after party, and then I need to make my bounds 1 and 2. So this was given to you in the last after party as a graph, and all you had to do was say, okay, I'm not going to subtract the area that's below the x-axis, I'm just going to add that, and y'all were good with that, but this is not the same type of problem. You could make a graph, like you could find all the zeros, and then you could switch those integrals, and that's really how I did this when I was in school. You guys gotta get out of this lucky because you're kind of almost expected to use technology. So, and the calculator, if you haven't finished the after party, I would like really be paying attention right now. And especially if you've kind of zoned out a little bit. So here's the integral. V of t, that was x squared minus 4 divided by x, and I could be using t right here. And then, oops, I forgot the absolute value bar. Anybody else wondering about that? How do you get absolute value? Okay, so there's different ways to do it. I really think the easiest way is catalog because it happens to be the very first thing.
Oh.
All right?
You could just say.
And that's an extra parenthesis, so I'm going to erase that. So I'm going to take absolute value of that, then again, comma x, and if you have bounds, you're going to put those in. This saves you not a little bit of work and time, a lot of work and time. Now your calculator, what did I do wrong?
You close the
You added extra.
I closed too many parentheses.
Just click your back button.
Yeah, but I need to take absolute value and all of that. Open, close, close.
So
I need to open another one
Right there.
in front. So I erased one that I needed. There we go. And then again, I want you to look right here and say, is this what I really wanted to do? If you mess up on parentheses, it's either going to yell at you, like mine did me, or it's going to look weird right here. Okay? Some calculators take longer than others to do this. Some people did this and it took their calculator almost a minute, but it said busy while they were doing it. It kind of just depends. So as long as it says busy, it's thinking, okay? So I think y'all should all be doing this in your calculator to make sure that you're getting the same answer. Okay, now keep in mind, this is the total distance. This is not how far the particle is from where it started. All right, so 1.273. And there's no units on this. So that's how far this particle traveled. Any questions on that? I was kind of hoping this lesson would come a little bit earlier before the after party was due, but still, we got 2 more days to do this. And this is the part that I think most people are going to have trouble with. Okay, so your homework tonight is going to be to do this next page, this worksheet, okay, and all the way through to 10. All right, that's your homework tonight. Your homework on Thursday night is going to be to do the rest of these problems. So if you want to get ahead, you could, but this stuff is not going to be on the quiz, so I'm just going to say your time is better spent on the other things, okay?